Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to Lesson 2, Construct an Equilateral Triangle. Classwork, opening exercise, you need a compass and a straight edge, and another student's problem set. So you're going to take a student's problem set from the last class, and you're going to follow their directions on creating an equilateral triangle. So hopefully their steps went kind of like this. So the first thing you're going to do is draw a line segment. So I'm going to pick endpoints with points, and how about that thick, and let's go with red. And I'm going to draw a segment anywhere. Not real big because you don't want to go off the paper. Alright, so there's my segment right here. So I'm going to put it right there. That segment is 1 3/4 inches long. Actually, I prefer using metric, so let's flip it over. 45 millimeters. Okay. So you would have drawn that with your straight edge. And then what you should do, label each end A and B, A, B. And then I'm going to take my compass and put the point on A and open this up to B and create a circle. Alrighty. So then I'm going to flip this around, move my point over to B, like so. Let's change the color to blue and draw a circle. So I've drawn two circles. So circle with the A center has a radius AB. Circle with center B has a radius BA. Well, they're sharing the same radius, so the radii are equal. AB equals BA. And any other radius anywhere else on the circle will be equal to that radius. So now I can just take a point and plop it right here at this intersection. And there is my equilateral triangle. So I'm going to take my straight edge and put it right here and rotate it up to that and draw a segment. And then I'm going to move that over to here. Alrighty. Rotate it around and draw a segment. And then if I hide or delete my circles now, I have an equilateral triangle. This was 45 millimeters. Therefore, this is 45 millimeters, and this is 45 millimeters. Okay, equilateral triangle. All triangles have 180 degrees in them on a plane. So 180 divided by 3 is 60. So that means that every angle must be 60 degrees. Equilateral triangle. Okay, so there you go. So then I can't really do this for you right here. It says what kind of problems did you have as you followed your classmates' directions. Think about ways to avoid these problems. What criteria or expectations for writing steps in construction should be included in a rubric for evaluating your writing? List at least 3 criteria. So what they're trying to do here is, if you are not able to do this by following your friend's directions, and that should be a C there, if you will, then fix those directions so that it doesn't happen again, because if you can write directions and someone else follows it correctly and gets what the outcome is, the outcome you're looking for, then you're well on your way to doing constructions. Okay, page 2 brings us to an exploratory challenge. You need a compass and a straight edge. So the first thing we're going to do is get a straight edge and a compass. Okay, you'll need to do the same. Using the skills you have practiced, construct 3 equilateral triangles, where the first and second triangles share a common side, and the second and third triangles share a common side. Say that again. We're going to make 3 equilateral triangles, where the first and second triangles share a common side, and the second and third triangles share a common side. Clearly and precisely list the steps needed to accomplish this construction. Switch your list of steps with a partner and complete the construction according to your partner's steps. Revise your drawing and list of steps as needed. Construct 3 equilateral triangles here. So pause the video, see if you can do this, and then come back and we'll see how you did. Okay, so to construct a equilateral triangle, step 1, I am going to draw a line segment and call it AB. Okay, so actually I'll just use my pen. I won't cheat. Pen, let's do it in red. And I'm going to draw a segment. I'm going to start at 0 here and draw it out to, how about 5 right there. Okay, so there's a segment and we're going to call it, we're going to call it AB. So here's A, here's B. So step 1, draw segment AB. The next thing I'm going to do is draw a circle, A. And here, let me move this though, because I don't want to be off the paper. So let's put this, oh, I don't know, right about here. You want to be in the center of your paper, I suppose, so hopefully you didn't start way over like I did, but it'd still be okay because you just wouldn't see the whole circle. All right, so the next thing I want to do is I want to draw a circle with center A and a radius AB. So I bring that out and I draw my circle. Okay, so there it is. Okay, so I said to draw a circle A, center A, radius AB. So there it is. Step 3, I'm going to draw circle B with a radius BA. So this is just going to be like this. Let me change the color of it though. And so I'm going to draw a circle here. Okay, so now I drew a circle B, center B, radius BA. Okay, list that step. Okay, so now what am I going to do? Well, we have intersection points. We can find C, label one intersection as C, and label the other intersection as D. So we have 2 intersection points. So let's label them. So I will put one here. And let's label that one C. And then put one down here. This is an intersection point. And I'm going to call that D. And now we're just going to say that. Okay, so label one intersection as C and label the other one as D. C and D. Okay, the next thing we want to do is draw circle C, center C, radius A. So now I'm going to draw circle C, so I'll put this here. Here, let's rotate it so it's on the paper. So I put this here, and as you can see, this will be the same. See that? Because we've already drawn the radius, it's the same, it's a circle with the same radius. So there's the circle. I went off the screen. Well, let me move. Okay, so there's that. So I just drew circle C, center C, radius of A. Okay, so now I just want to draw in CA. So let me bring my ruler in. Put that there, rotate it up to C, and draw my line segment from A to C. So there's that, but while we're at it, we could probably draw and label BC as well. shorten that a little bit. There we go. And I erase my B. Okay, it's a little tricky with the electronics here. Hello, I could press that. This is B. Okay, so let's recap. 1, draw segment AB. 2, draw circle A, center A, radius AB. So when it says radius AB, I guess that's when we should draw that segment. Draw circle B, center B, radius BA. It was already there. Label one intersection as C, the other intersection as D. Draw circle C, centered C, radius CA. Radius CA would also be equal to radius CB. Okay. So what have we done so far? Go back to the problem. Question. Using the skills you have practiced, construct 3 equilateral triangles. So far we have 1. Where the first and second triangle share a common side. So now I want to make another triangle using either AC or BC or AB. Okay. So I'm going to use AC. So the next thing I'm going to do is label the intersection of C, of circle C, this circle here. You can either label its intersection with circle A, which would be here, or circle B, which is over here. And we'll label it E. I'll use this one. I'll go this way. Doesn't matter if you use this side, that's fine. But I'm going to do that, and then I'll just bring that verbiage in. Okay, so here it says label the intersection of circle C with circle A. And then it says or intersection of circle C with circle B over here as E. I chose to go this side, but you could have gone over here. So that's what that says. The next thing I'm going to do is I'm going to draw all the segments that are congruent to AB between the labeled points. Okay, so I could have waited to do these black lines till now. All right, so now I'm going to draw a segment from A. Let's do it all in, well, let's do different colors. How about purple? From A to E. And then I'm going to rotate this up here and go and draw segment EC. Okay. So, what have we just done? It says construct three equilateral triangles where the first and second triangle share a common side. So triangle ABC and triangle ACE share side AC. Good. And a second and third triangle share common side. So now here's my second triangle, and I want to share a common side with a third triangle. So I want another triangle over here. Okay. Well, how am I going to do that? Okay, so if I take my ruler and put it back here, right on this line segment here, let's change to green this time. Now, AB was that line segment that was how long? 5 centimeters? Okay, so if I draw a 5 centimeter segment over here, it should be equal because this is also a radius. So this point over to here is also a radius. So that green line is the same length as the red line, is the same length as the black lines, is the same length as the purple lines. And I found this point right here just by using my ruler. And then what I can do is just put my ruler at that point, rotate it up to E, and draw my final side. So there are 3 equilateral triangles. My original is ABC. My second one was ACE, and it shared side AC. And then they said to make a third triangle that shares a side with the second. So I have triangle AE, how about F? And AEF and triangle ACE share side AE. So the last step says draw all segments that are congruent to AB between the labeled points. Okay, page 3 brings us to exploratory challenge 2. And it says, on a separate piece of paper, use the skills you have developed in this lesson, construct a regular hexagon. Okay, remember hexagon's a six-sided figure. Clearly and precisely list the steps needed to accomplish this construction. Compare your results with a partner and revise your drawing and list of steps as needed. So think about what a hexagon is. It is 6 triangles centered where all the vertices come together at the center of the hexagon, if you will. So see if you can do that with that little hint. Pause the video, see if you can do it, and then come back and check. Okay, so here we go. I'm going to start with my compass, and I'm going to make a circle. I'll make the ink blue. And how about stretch it out. I don't want to make it really large. I want it to stay in this space. I guess that would be good, I think. Maybe a little bigger. Okay. And then I just go around like so. And there's my circle. So I'm going to start with a circle. And it's going to be centered. Actually, I should have undone that. I should put a dot where I'm resting my... right there. Okay, now I'll move that out of the way. So there's the circle. We want to name it. I don't know, it doesn't matter. How about we name it? Let's see, a six-sided figure. A, B, C, D, E, F. All right. So I'll make this G. So there's circle G. Or how about we call it K? Circle K. All right, so there's circle K. Okay, so step 1, draw a circle K, center K, any radius. Well, it can't be any radius that fits on the paper. Okay, so now step 2, pick a point on the circle, label this point A. All right, so pick any point, it doesn't matter where it is. How about right there? And I will call that point A. Hey. Why are you back to blue? I want red. A. So there's A. All right. Now I'm going to take my compass, move it over to A, and draw a circle through the point K. So now I have two circles, and if I drew a line segment, actually, let me do it as if I were just on paper like you. And I'll draw my sides green. Actually, I don't want to draw lines from A to K. I don't want to draw lines to the center. That's not going to be helpful. We just have to find where the next point is going to be. All right, so anyhow, there's A. So what did we just do? Okay, so I kind of did 2 things there. So I brought in 2 descriptions. Okay, after we drew circle K, we put a point on the circle and labeled it A. That's right there. Then we drew circle A centered at A with a radius of AK. All right, so there we have it. Then we're going to label the intersections of circle A with circle K as B and F. So now I'm going to label this point right here, B, and this point here, F. Why is that? Well, A, B, C, D, E, F. F is the 6th letter in the alphabet, so there's one side, then 2, 3, 4, 5, 6. Okay, so there we go. Okay, so number 4, label the intersections of circle A with circle K as point B and point F. Okay, so now that we've done that, now we're going to move around and keep doing this. So now we need to draw another circle centered at B with a radius of BK. So I'm going to bring my compass over and put it right there on B and draw a circle. Notice it goes right through K because all of these have the same radius. and now I have a new point, new intersection with circle K. I don't care about this point out here. I have a new circle intersection. I'm going to call that C. So that's this point right here, and that is C. Okay, so I drew circle B, center B, radius BK. All right. I also labeled the intersection of circle B with circle K as point C. I don't need to label point A again. It's already there. Circle B went through point A as well as C. So notice what's going on here. We now have sides starting to form. We have FA, we have AB, we have BC. We have a four-sided figure now. We just have two more to go. So now I'm just going to repeat the process by bringing my point down, centered at C, and drawing a circle. Notice it went through K again, and it went through B. And then now I have a new point right here, and that is going to be D. Okay, and I'm going to do it one more time. Bring your compass down and put it at the point D, and draw a circle through K again and around, and I created a new intersection right here, and that is going to be called E. Okay, so I don't need to draw another circle here, but if I did, it would end up, if I put my center at E, just to prove that to you, it will go through F and it will go through K. So there's F intersection, K intersection, and D. Okay, so these are all circles. There's how many circles? 1, 2, 3, 4, 5. And then the blue one is 6. And then if I wanted to do it again from F, that'd be my 7th circle of the same radius. So if the radii are all the same, then all the segments that connect these dots will be the same. Okay. So once you do this a few times, since it's the same thing over and over again, you can just say something like, continue to treat the intersection of each new circle with circle K as the center of a new circle until the next circle to be drawn is circle A. So I did that. I drew circle D, then circle E, then circle F. The next one would have been A, and I stopped. Now we just need to draw line segments from A to B, B to C, C to D, D to E, E to F, and F to A. So I'll do that with my ruler. So I bring it up, I put it on A, I rotate it. So you need to do the same thing, be very accurate with this. And let's use purple for the side. So I'm going to start here and draw a segment to B. Move this to B. Rotate it so that it's going to C. Let me put it on B a little bit better. And draw a line from B to C, or a line segment I should say. I bring my ruler down to C's, the 0 is on C or close to it, like so. Rotate it to my intersection at D. Draw a segment down to D. Move my ruler 0 to D. Rotate my ruler so I'm going to E. Draw a line segment to E. Move my ruler 0 to E. You wouldn't have to do this because on paper you would just line it up, but this is the easiest way for me to line it up electronically. And then I draw a line segment from E to F, and then finally put my 0 on F. Oops, put that back. Rotate it to A. Draw your segment. Move my ruler, and there is my hexagon. So what is my last step? What am I going to say? Okay. Okay, so I say draw segment AB, segment BC, segment CD, segment DE, segment EF, and segment FA. So there is my hexagon. Now I'm going to take a moment here and delete all my circles just to show you what this would look like after we get rid of all of our construction marks. And boom, there is a hexagon where all the sides are congruent and all the angles are congruent. Now it says here, can you repeat the construction of a hexagon until the entire sheet is covered in hexagons, except the edges are partial hexagons? So what they're asking is, let me do this. Okay, so what I did there was I copied it. If I brought this down and just set that right there, there it is. Do another one, bring that here. Okay, put that right there. Bring another one in, put that one here. Okay, now notice these aren't perfect, but you get the idea. They're very close. So what they're saying is, could we just duplicate this? This is called a tessellation, is the actual terminology for this. So that's what it would look like. So it would kind of look like a beehive. All right, and I could continue until there are partials. So let me do it one more time, and you'll see what it means. So if I had this partial, and I put it right here, and this was the wall, then that's what it means by there would be partial edges. The edges are partial hexagons. So like right here, this would be a hexagon, but it ran off the paper. So if you were tiling and this was your wall, you would cut the tile so it would fit tightly up against the wall. All right, so there it is. So yes, you can repeat the construction of a hexagon until the entire sheet is covered in hexagons. Think of it as wallpaper, and it is called, if you want to know, a tessellation. Okay, page 4 brings us to the end of lesson 2. Go do your problem set.